All right. So, welcome. We are going to be talking about people, pups, and poop. And you know that you are in a room with water quality professionals, enthusiasts, and advocates with a title like that. And we, going a little bit further, are going to be talking a bit about using eDNA analysis to address bacteria pollution in local waters. My name's Peter Linderoth. I'm the Director of Healthy Waters and Lands at Save the Sound. I'm joined by a really great group of presenters that'll be joining and sharing information with you all today. Just to set a little bit of the introductory kind of groundwork, we do have a fairly large group we're expecting joining, so please use the Q&A function for your questions. We're going to hold questions or answering your questions until the end. So please use the Q&A. You're welcome to use the chat though if you want to tell anyone they're doing a great job and encourage them, or just put any chat that you have or information sharing you want to do in there. And don't worry, we won't hold it against you if you use the chat for questions. I just wanted to bring that up. So, as I said, we have a really full room of presenters today. I already mentioned who I am. Here are the other faces, the talking heads, not the band, but the people today that are going to be talking to you. I'm going to go ahead and introduce each one of them before they come up. But look, they're smiling. Look at Elena Cologne's smile right now. You'll be seeing and hearing from this group, everyone just as interested in cleaner, healthier local waters in the Long Island Sound. So, really, really stellar cast. Thank you all for joining. A little bit about Save the Sound. Our mission, and I'm not going to read the mission here. I think the heart of our mission is protecting, restoring, and I like to add, I'm going to get on the mission committee when we update the mission, protecting, restoring, and understanding the land, air, and water of the Long Island Sound region. We are a very diverse set of people, different backgrounds, all working towards the same goal, though: cleaner waters for Long Island Sound, cleaner lands around the Sound. And it's really a fantastic place to work. I've been here for over 10 years. I love it. The Sound's near and dear to me, as you've maybe heard me say before. So it's really an honor working with my colleagues. A big part of what we do is related to the Clean Water Act, and I'm not giving a Clean Water Act lesson today, I promise. But at the heart of the Clean Water Act, there's a section often called the swimmable, fishable section of the Clean Water Act. And that says there's a national goal, wherever attainable, that all the waters of the U.S. will be swimmable and fishable. And that, I forget when the date is. I saw our former president and attorney Kurt Johnson joined. He probably could drop that in the chat at a heartbeat. But that date is passed. We're still working on making all the waters swimmable and fishable. But what we're talking about today relates a lot to swimmable. If you're like me, I love the winter, but I'm very much looking forward to days like we're looking at here in this image, where I can go out, go swimming, bring my family swimming, enjoy the waters of Long Island Sound. And of course, when I do that, I don't want to get sick, and I don't want my friends and family to get sick while we're in the water. So what we're discussing today relates to how healthy the water is for swimming. And specifically, when you go to the beach, there's a health department typically that's taking samples. There you go, Kurt. Thank you. 1972 Clean Water Act passed. And Kurt, for bonus points, when were all waters supposed to be swimmable and fishable? Um, in terms of swimmable, health departments use pathogen indicator bacteria sampling and literally collecting bottles of water at the beaches that we like to swim at and processing them for enterococci or enterococcus in marine water. Those are our sound beaches, or E. coli in freshwater like ponds and lakes. And if those bacteria results come back high over these thresholds, these exceedance values of 104 and 126, those are concentrations, a beach can be closed, an advisory could be issued, different things can happen, but pathogen indicator bacteria, it's important to remember, are used now to determine, is that water healthy for people to swim? Does that beach need to be closed? Does an advisory need to be issued because people might get sick when they interact with the water? The thing about pathogen indicator bacteria is that they could come from any warm-blooded organism, right? We don't know if it's people or pathogen indicator bacteria from our waste, or if it's geese or dogs. But that is the system that's in place right now to gauge, like, are those waters going to make us sick? Are pathogens present in the water? A big pillar of what Save the Sound does is data to understanding to action. If you are following along with our work, you've hopefully seen the Long Island Sound Beach Report. We've issued quite a few of these now. This report aggregates data from over 200 Long Island Sound beaches, specifically that pathogen indicator bacteria data collected by health departments, and issues grades because most people understand A to F, green through red, better than however I may have just botched my pathogen indicator bacteria introduction and what I was talking about before, right? A through F, is that water consistently good for swimming? Is it not meeting that criteria often? This beach report packages that up for people in a way that's very understandable. I'd really recommend people check it out. You can also see the digital version of the beach grades that are in this beach report on soundhealthexplorer.org. One of the beaches that's going to be discussed today, and I can do a lot of talking, so I'm about to pass it over shortly, is Johnson's Beach. It's in this beach report. It has had its set of challenges over the years, but we're going to hear some really great information from our speakers on how they evaluated the challenges at Johnson's Beach in relation to pathogen indicator bacteria pollution, and how they've been able to hone in on specific challenges that have faced the water quality at their beach. This slide shows a whole host of things that can introduce pathogen indicator bacteria to our beaches: stormwater, leaking sanitary sewer pipes, cesspools and septic tanks that aren't working correctly, dog waste that's on the streets that's not picked up. As cute as geese are, if you've walked to the beach during the summer and you've stepped on these big green cigar-looking poops, those are from geese. They can really interfere with water quality. And in our beach report, we can't tell everybody exactly why a beach is getting maybe a D and F or consistent Cs over the years. We don't know exactly which challenge it is, but it does serve as a roadmap to beaches that could use some extra attention. And the people we're about to hear from really did take that next step and evaluated the challenge to their beach and put some solutions in place, which is awesome. I'm really looking forward to getting started with them. So first up, we have Mike Pasquasilla, the CEO, Director of Public Health at East Shore Health District. One of my favorite people. I like and work with lots of health departments, but Mike's always a pleasure to talk to, and he's so forthcoming with information. Mike, thanks so much for coming today. Take it away.
All right. Thank you, Peter. I guess I want to start off by putting a shout out to our New York colleagues. So this is not just Connecticut based. This is also New York. We share the sound. It is our playground where we work, live, and play, and we all want to protect it. So I just want to put a shout out to them. If you want to go to the next slide. So I guess let me take you through my journey. So this is a 16-year project with us questioning why are we consistently opening and closing beaches. So traditionally, at the public health level, we open and close beaches. And while it is a necessary public health measure to protect beaches and shellfish, we also have done preemptive closures based on rainfall. You see that a lot with shellfish, but you also see it with beach water, something that we have done. It doesn't get to the root cause, like what is the source of the contamination. And so 16 years ago, we started this process with a student, Lauren Brooks, from Yale University, and has transitioned to other students in other schools. So a quick background. Johnson's Beach, also known as Clark Beach and Short Beach. And those of you who collect water samples know that, neighborhoods have all their different names for their beaches. So if we look at Johnson's Beach, which is the official name, we had the fourth worst, our highest bacteria counts of 37 beaches in Connecticut, not a place that we wanted to be. We had high bacterial counts, beach closures for many years. And so we looked at the previous studies that go back to about the 1990s, and it never identified what the source was. We're also doing work in the Farm River on the Branford East Haven line. Because right now, because of high bacterial levels, you can't swim in it, and shellfish is not edible. And it exceeds the recreational bathing water standards. So let me start with some of the good news, and you're going to hear about the process and what we've done in that area with our town partners and the community. But to go back in 2019, the beach was a C minus. And through interventions, through the extension of um, improvements, storm water, sewer extensions, and things like that, we brought it up to a C plus. And then through the microbial source tracking that you're going to hear a lot about, last year we were a B. And I'm happy to report that this year we have maintained that status, although there is room for improvement, and we're going to take this study to the next step. But we're, while a B, we're proud of our B, but there is room to take it to the next step, and we plan to do that with this technology. So what we did at the health department is for our water quality research, we turned it into a citizen science project, right? So we had the community that participated in our research. They were part of the solution because as a government agency, we can only go so far because in the end, it's up to the community to uh, be engaged. In fact, the community not only helped us with this study, but they had identified storm drains that weren't even on our maps. So we used a technology called Microbial Source Tracking. You're going to hear more about it. The community um, provided about $20,000. The town of Branford provided another $20,000. And then we asked for an additional $18,000 for the project for the community investment. And so we've been able to do this technology, which is quite expensive, and it's really made a difference. The research has been published at the National Environmental Health Association. We've presented it across the country and the state. In fact, a few years ago, a year and a half ago, we presented it at the European Public Health Association in Lisbon, Portugal. And we've talked to the EPA about getting this to the next step for a tool for all local health departments. I just want to note that this would not be possible if it wasn't for, one, the community, the Connecticut State Department of Public Health Lab, our town partners, the Branford Community Foundation, local representatives, and again, the community and businesses. And I have a few pictures here. If we could just go back. I just want to just point out, and you'll see some of these pictures, but I want to point out the church. We had community meetings in a church. And when we talk about working with the community, it is important to bring and go into their neighborhoods. This is their turf. And this little church, we have been and continue to meet to talk about how we can improve water quality. Next slide. So if I had to summarize why citizen science is so important, it's not just engaging the community, but it's all about relationships. And that is what has made this practical research and policies that we put around it very successful. And it's about trust, transparency, stakeholder engagement. And I just want to note that influence goes both ways, right? So yes, we are a government agency. We're here to help and, to do our part. But the community has expectations of us. And so it's a mutual understanding. There's a human component of sincerity, and just being authentic and real and having those hard conversations is really important. And of course, innovation. And the innovation here is we're using a technology that EPA uses, although it's not EPA approved. Next. So community negotiation strategies, it goes back to basics. We had to listen to the community. It's a local issue. We had to present, and what we've been doing is getting credible data, common ground, meeting on their turf and talking to them and listening to what they would like to see in their neighborhoods, because in the end, they're the ones that made it happen. Respect communication. Again, influence goes both ways, and that's just with any relationship. We had to separate the people from the problem, and I just like this saying. The strength of our nation at its core is truly in our local communities. Next slide. Um, so here are some pictures of poo that we've been taking, and as a runner, I will tell you, everywhere I go, I see it, and then the more I look for it, the more I find it. And now the snow is melting, and so I got a snow picture there. I call this the poo of shame. And it's not just the poo that we're seeing, but it's also the plastic now. We're seeing these plastic bags, these smush bags, piles of bags. And so while we're seeing this in our community, in the town of Branford, I will tell you, everywhere I go across this country, and even when I was overseas, it's happening everywhere. Next slide. Um, I want to point this slide out because, again, we have a strong academic partnership, and that has been key to this project. And so Yale University, along with Southern Connecticut State University, Brown University, you're going to hear from Sarah in a few minutes, have really been instrumental in this research. But this particular slide was made by Southern Connecticut State University, and there's some marketing and branding that we're doing. Next slide. Um, so Long Island Sound. I grew up on Long Island Sound. In fact, when I was a kid, my Italian grandmother used to send me to the beach and tell me, Miguel, go and get me some clams. And growing up on the coast, and fishing and clamming and collecting oysters, and I'm a boater. um, it is what makes where we live so special, both not just in Connecticut but in Long Island Sound. And I'm also a dog owner. That's my dog, Kyle. And I just wanted to, put the human component of it. My son has a sailboat, and we fish and sail and enjoy everything that Long Island Sound brings to us. Um, and so leave you with this sense of belonging. And what we want to do is create our little blue zones. And where we live matters. Your zip code determines the quality of life. And local public health and community engagement, they go hand in hand. And if you want to have a good, healthy community, it is a partnership. And again, I just want to put a shout out to all our partners. While we are leading this project, we're co-leading it with our community, with our town, with our academic partners like Yale, Southern, Brown University, and others. The Connecticut State Public Health Lab, we would not be where we are without their help. I have to acknowledge them and everything they've done for us. Our town partners, the Branford Community Foundation, who we got some grant funding, a local representative, and of course, at its core is our local community and businesses. And when I was recently presenting this data, I went for a run and I saw this picture in an Arizona neighborhood. And fight for the things you care about. And I really think that for me, that's for me, Long Island Sound is what I care about with my family, and it is why we live in this special place. And so, with that,
Thanks, Mike.
that's my
Yeah,
presentation.
thanks. Thank you, Mike. Thank you. That was great. And realizing we have probably over 100 attendees now, just about, and we have people from New York, out on Long Island, New York City, coastal Connecticut, you name it. Everything we're hearing about today is very applicable beyond whether you want to call it Johnson's Beach or Clark Ave Beach or Short Beach. This story is, and this what we're hearing about these activities apply, you know, regional. They can apply in lots of different places. So thank you, Mike. And next up, we have Sarah Essenther, the water quality coordinator at East Shore Health District. She's going to dive into the data, as we like to say, and get into a little bit more of the results of the project that Mike was setting it up. Take it away, Sarah.
Yeah, thanks, Peter. So this project happened in a number of phases. It originally began in 2019. At that point, we did not know what the cause of the fecal matter in our water was. We just knew it was there. And we all assumed that it was human bacteria. So the first year, 2019, when I joined, there was no microbial source tracking. It was all trying to figure out where are the leaky septic systems, where are the leaky sewer systems. So for that year, that was when we first got involved with the community and we worked with a citizen science campaign. One of the issues we have from the health department is just the travel time to get from the health department to the community to be able to take samples after precipitation was enough of a delay that we weren't able to capture all of the data. And that was really the reason that we started partnering with the community members, is that they live in these houses right next to these outfalls and they can get the data as it's happening. So 2019, we worked with a number of citizen scientists, and we did find some important discoveries that year that really shaped the project going forward. One was that this is definitely a non-point source pollution problem. It doesn't seem like there was one leaky septic system or one area where sewage was flowing into the waters. It was a little bit more complicated than that. We were also able to identify an additional outfall that we did not know about in the town of engineering records. This is a very old neighborhood and predates the health department itself. And so we just don't have records and don't know the neighborhood the way that the people who live in it do. After the citizen science campaign in 2019, there was a bit of a break when the COVID pandemic hit. In the meantime, the health department worked on putting in preemptive beach closure thresholds. So based on the data we collected in 2019 and before, we set limits. If it rains more than a certain amount, the beaches and the waters are automatically closed. And this was an interim measure we took to protect the health of bathers and people recreating in the waters until we could get a better idea of what was going on. 2023, the pandemic was more behind us, and we started working with the community again to really figure out what was going on in that neighborhood. And I want to point out that, as Mike said, this was really a very community-involved program all the way along, not only with our partners at the town of engineering, but we did receive community funding from different local charity organizations, from the Civic Association itself, some funding from the town of Branford, but then also the State Public Health Lab really went out of their way to help us run some of these samples. So all the way along, you're going to see this partnership as a strong theme in the work. So microbial source tracking is a technology that lets you identify whether bacteria from a species is associated with a certain, or is associated with the fecal sample you've collected. So we knew that we had high E. coli in our waters. Among the very high E. coli samples, we could test them and see if there were markers from human or avian or canine. When we began this again in 2023, we worked with the community to figure out what that list of samples was. Human was always a suspect, and especially as the health department, we're really interested in that because that poses generally the strongest threat to human safety if there's human bacteria in the water. But the reason to include dog was in conversation with the community members in that first year. So on the map, you can see these are the locations that we sampled throughout Short Beach. These locations are ones that have storm drains that we were able to clean out and were able to sample, and all have outfalls that go directly into the Long Island Sound. So you can see right around the CA1, CA2, CA3, that's Clark Avenue. So that's the beach that the beach report is written about. But there's also a number of other beaches that people use in this neighborhood. And we were really interested not only in focusing on the one that was getting the report, but on all the ones in the neighborhood that people are using. And so we wanted to include sites that fully encompass the neighborhood areas people were going to be swimming in. Microbial source tracking is still a pretty new technology, especially in public health applications. So at this time, there are no EPA guidelines. There are no standards that you can say, this result is exactly related to this many bacteria in the water. You can't compare directly across species. So it's important to keep in mind as we start to get into the results of our testing. The avian results and the canine results are on different scales. And so each one is comparable to itself. You can compare canine results across years, but you can't directly compare in between species. This was posed a little bit of a difficulty for us as we were trying to figure out what the main source of the contamination was. And so to try to get around that, we worked with the Lumen Ultra Lab, which was the private diagnostic testing lab that ran our samples for us. And based on their recommendations, we used the cycle threshold value. You can see I've colored it, the results going forward from here in blue for low, yellow for medium, and then orange for high. Again, these are not formal standards, but this was based qualitatively on our experience in the neighborhood and their experience running these tests for a lot of different groups. So after that first year of testing in 2023, these were the results we have. Again, we can't compare directly across the species, but there were a number of things that really brought our attention to canine waste. These are all samples that were collected from very high E. coli levels. So this was all E. coli levels that you would not be able to swim in. Many far exceeded standards you wouldn't be able to kayak in or boat in. Some of the samples that had the highest E. coli generally also had the very high canine counts, which was the first hint that really pointed us towards canine bacteria being a big problem in this neighborhood. Another one was the distribution. The following precipitation events, we saw very high canine bacteria essentially everywhere when we were seeing the highest E. coli. But canine was also most concentrated at the sites where we were having the most chronic problems, and the beach water had had the most issues in the past. So based on this, and also some qualitative work for our discussions with that diagnostic testing lab, based on their experience, the canine bacteria was often in 1 to 2 orders of magnitude higher than they were used to seeing, while the avian and the human were more in typical ranges. So we can't compare across, but just based on their experience and what we were seeing in the neighborhood, we really zeroed in on canine as our most likely suspect in 2023. This led to a two-part response. One was some infrastructure improvements and work on the town side, and the other was on the community side, which Ali will talk about in a few more minutes. On the town side, though, Public Works and the Engineering Department and the East Shore District Health Department all worked together to do a number of improvements. One was some drainage improvements at this dog park, which was in Short Beach. Previously, there was an open outfall or storm drain where it would take waste from this and have it run directly into the water. Now that's been covered, so there's a little bit more infiltration to try to get the bacteria levels down. The health department did a number of public presentations and helped with the one-page mailer design that was distributed to all the homes in the neighborhood. We also worked with different vet offices and pet stores, places that animal lovers would be congregating. We might be able to get their attention to do some education on the importance of picking up after their dog waste. Although we were not especially concerned about human bacteria at this time, given the results that we'd seen from the MST, we did camera and reline the sewers in the neighborhood just to make sure that that wasn't going to be an issue. And then the health department also did resampling. And these are the results of the resampling. Again, we can't compare across species, but we can compare directly between years. So you can see that from 2023 to 2024, there was a very large drop in the presence of the high and median canine markers in the neighborhood. These are all among the very high E. coli samples, so these are the ones that we're most concerned about. And between 2023 and 2024, we saw a drop from 85% to 17% in those moderate to high markers of canine bacteria. Avian stayed about the same and human went down a little bit. Some of the human decrease might have been because of the interventions that we did for the canine bacteria, things like covering some of the trash cans, so runoff at the beach might not be washing diaper waste into the waters, things like that. But the real headline of the story is that we haven't had any beach closures at Johnston's Avenue since we did this intervention. And this was a beach that was often closed 2 or 3 times a year before that. So we're thrilled with the results that we've had from this intervention. So just as some final takeaways on the science side of this before we talk more about the community piece with Ali. We've been seeing lower E. coli following precipitation. The slope between precipitation and E. coli we're getting has been lower at our sites since this intervention. And again, we haven't had any beach closures, which was really the main goal of this project, which is really encouraging because it means we now have a roadmap for the future. We now understand where this waste is coming from. And so if we start to see these levels creeping up in the future, we have a strong suspicion that it's coming from dog waste again, and we have a known roadmap for what we can do, what implementations, what community partners we can lean on to really get that bacteria back to where it is now, to where we want to see it. We're still focusing efforts on a couple of remaining hotspots, but really at this point, we're transitioning the project to the community. This project was done in collaboration with our community partners, and at the end of the day, this is their neighborhood, and they're the ones that are able to protect it better than anybody else. So with that, I'm happy to pass it on to our community partner.
There, thank you so much. That was fantastic. And what a great example to the community kind of getting behind the data, working with the environmental scientists, collecting samples, and it's such a great model. I know I already mentioned that, but such a good model for any beach that's having challenges like this. And one of the things I didn't maybe I may have missed you say is, but I've heard you talk before, and you and I have met many times. Sampling frequency. You made a point of really having abundant sampling. Can you shortly speak to that?
Yeah, so in 2019, before we started with the MST work, one thing that we really struggled with was sample frequency. We were trying to get the samples after precipitation events when it was flowing hard enough to be able to
Right.
discharge into the sound. So we, in 2023, started sampling from the storm drains. So these are the areas that fill up enough to then discharge into the water. And doing that switch allowed us to sample weekly instead of just when it rained when the state public health lab was open, and getting the better picture of the data both under dry conditions and under wet conditions really gave us a bigger picture of what was going on here. Some of these sites had very high E. coli even under dry conditions. It was always higher with precipitation, but that really helped us nail down on areas around where there's a lot of dog walking, around
Right.
beaches where dogs are very common, where
Yeah.
that was another hint towards us thinking that canine was probably a main driver of this waste.
Thanks, Sarah. And Tina, it's good to, I just saw Tina put something in the chat. I feel like I haven't talked to Tina in a while. It's a really good question. We'll make sure to get to it at the end. It's one that I've asked you too, why you chose E. coli over Entero and brackish water. And I know you have an answer to it, but let's get to it after Allie. Let's make sure we give Allie some time. So thank you again, Sarah. Um, so next up, we have Ali Boulier. Pardon my French. I hope I got that right. From the Civic Association of Short Beach, Sanitation Committee member. Take it away, Ali, please.
Thanks so much. So as you can imagine, we were so excited to have this data and learn what was causing our water quality issues, and especially to learn that it was dog waste and not human waste. Much easier to fix, we thought. And we knew we needed to make sure that everybody else knew that this was the problem. So what did we do? We designed a branded campaign with a logo and slogan. Mike mentioned that we often met at the church in our neighborhood, and this is true, but we also met at each other's houses, in backyards, and on decks. We brainstormed and discussed what colors would resonate with our community and what slogan would be just right. And a graphic designer from the neighborhood made this logo for us. And you've seen it a few times in the presentation. But it's right there in the bottom of this graphic with the dog. We also created messaging that was informed by behavior change theories because these increase the likelihood that people would actually change their behavior. So this was language such as, thank you for doing your part on some of our signs. And we also had signage all around the neighborhood, which served as cues to action. At one point, I think it's safe to say you couldn't walk 10 or 15 yards without seeing a campaign sign, and they're still all over the place. We spent a lot of time thinking about how to best reach people, and we knew that we needed to do so in a variety of ways. So we mailed community briefs to every house. Even with community briefs, we thought about, well, mail is expensive, and we didn't want ours to get discarded as junk mail. So the Civic Association of Short Beach is a trusted source. They only mail information a couple of times a year. It's always important. So we mailed our information from the Civic Association of Short Beach, and we are confident that people this way would open it and read it and not discard it. We hosted community meetings where we gathered people in person to present the data and our recommendations for dog waste removal. We had an outreach table at our annual music festival. That's a block party where we gave away pins that people could wear. I just looked up and realized that I have a pin in my office. So this is what it looked like. We make pins in this neighborhood for many things. So in keeping with tradition, we made a pin for this campaign. We also had a dog parade. So something that was fun, something that was different and in the spirit of our neighborhood. And it was a success. People came out and watched. They ran to their front doors and clapped us on. And we had a reporter from the news that came. We also shared this information during through a radio interview with PKN. We used our neighborhood Facebook page to post information, and there are a lot of trusted messengers in the neighborhood, so they shared this news through word of mouth. The whole time we were very careful not to blame or shame dogs and dog owners. After all, many of us have dogs ourselves. We love dogs. We wanted to make sure that our message was clear and inspirational and motivational. Next slide, please. Thank you. I think all in all, we're really happy with how this turned out. Last summer, we conducted a survey to understand the effectiveness of our work and capture some community feedback from neighbors. So I'll just end by reading a selection of responses. I love the campaign. It's positive and fun, making me feel encouraged rather than coerced. When a poop station can is full, I don't put a bag in the regular can there. I walk it home. Your campaign is working. Thank you. Before the campaign and research, I believed that dogs were unlikely the cause of the poor water quality. I was very surprised and glad the campaign is educating more people in our neighborhood. The science tells the story and the campaign is clever and informative. I see less poop and fewer loose poop bags scattered around the neighborhood than in the past. It's been quite a while since I stepped in any. Most importantly, keeping our beaches and waters clean is the most important thing we can do for our health and the health of the sound. And lastly, thank you for putting in the special trash cans. I think it's helping. We're able to bring our out-of-town friends to the beach again. I'm glad to represent this work on behalf of our volunteer group. I know some of you are on the call, so thank you.
Ali, thank you so much. That was awesome. I love seeing the visuals, the signage, the logo, the branding, the dog parade. Do you do those every year now? The stop parades?
We have
I was
not,
inviting myself to the next one if you are. My
we
dog
have
too.
not
So
planned another
okay.
one.
Okay. I might loop back with you. If you do, I might make the trip up. It's such a beautiful little nook too of the coastline.
We'll be
Thank you
sure to
very
include
much.
you.
Thank you, Hallie. All right, next up we have Josh Brooks, the town of Branford, first selectman. We're really happy to have you with us. Thank you. Josh, please, the floor is yours.
Yeah, so I'm not actually Mike, but in the spirit of collaboration through all this, we're sharing a computer to give this presentation. But I was born here in Branford, and I have spent my entire life on Long Island Sound. I lived out there starting at the age of 9 days old, and in my previous life, I worked and lived on the Sound, and so I've seen the drastic changes uh, in that time period. A generation ago, we treated the Sound very differently. And then over time in the 80s and the 90s, with the direction of the East Shore Health District, we did a lot of cleanup as far as septic fields and sewer fields, and that direction really made strides to cleaning up the Sound. And then in the 2000s, as I recall, there became a push for the pump out boats, and again you see a drastic change in the activities of the Sound and just the overall quality of Long Island Sound. Uh, and so now we're here today, and it's 2025, and this is just the logical next step. This is the the thing we need to do now, right? We know there's a problem. We've through the science and these Sarah is much smarter than I am, and has shown the science of what we need to do and how we need to move forward, and the effectiveness of targeting intervention, and how we as a community, both on the government side as a community, but as the public as a community, can help assist in cleaning up the Sound. Here in Branford, we have 13 yacht clubs and marinas, over 1,800 boat slips, over 65 moorings, and life on the Sound is not, it's not a, it's part of who we are. It's what we are. And so protecting it becomes a vital part of it. I mean, it gives, We understand the public health benefits, right? The boaters, we're all in the water all the time. We go out, we shellfish, we don't always pay attention to the warnings. And, you know, having clean water helps us in our day-to-day activities, whether it's from fishing. I mean, I've been fishing my whole life. My grandmother used to make a lot of porgy sandwiches. My grandfather would send me out to get clams, and having clean water really helps who we are as people. The economic benefits also are endless. We have, like we said, we have all the yacht clubs, we have all of the boating, we have sightseeing. Having a clean sound helps with that. But we also have a lot of commercial fishing and a lot of shell fishing. We have seaweed farms, and those are big industries and vital parts of our industries, not just from an economic standpoint, but also from a historic standpoint. And protecting those businesses is not something you should do, but it's something you should do. It's not something that, well, it would be the right thing to do. It is a must to protect those businesses because they're part of the fabric of who we are as a community. The community benefits, again, a beach closed all the time doesn't help property values. It doesn't help quality of life. It hurts it. And so doing this work and keeping the beaches open and knowing that your water outside of your home is safe for your kids, for you, for the activities that you partake in using that water, it helps not just economically, but from a sense of community and a sense of pride. We in this community take cleaning up the sound as a sense of pride for us. It is not just a few individuals, but it's a community as a whole. Protecting the sound is something that we take very seriously. And so that brings me to my final comment. And my final comment is, while we are doing this program and we have made a choice to do this program, I don't think at this point it's a choice anymore. It's a must. MST has proven to be effective for us, and it is something that all towns should do and all communities around Branford, sorry, on Long Island Sound should be doing, because this, without Long Island Sound, it changes the dynamic of our community tremendously. We are not the same community without the sound. If this was the open ocean, this might be a different conversation, but you also wouldn't be able to have the same activities, the same flexibility in what you can do on it. And so we need to protect it because it's a valuable asset. There's no other place. I've always said there's no other place on the Eastern Seaboard like the Long Island Sound. So protecting it is not optional, it's a must. So I encourage, this, I will support this activity in my role now, but I encourage all of us to support this activity and continue to support this activity because the results are obvious and fundamental.
Thank you, First Selectman Brooks. I think that was really well said. And yeah, really encouraging to hear an elected official support this type of work so wholeheartedly. And also your point of a cleaner Long Island Sound and the trajectory we're on is just so encouraging. If we all at the local, state, federal level just keep pushing, we'll stay on this trend we're on now for cleaner waters for future generations too. So last but certainly not least, we have one of my main partners in water quality crime, I would say for the last 10 years, one of my colleagues. It's a lot of fun to work with. Elena Colon, she's going to talk about how Save the Sound has brought this technology into our laboratory in Larchmont. And I'm going to let her tell you about it, not me, as much as I'd like to talk about it. So Elena Colon, please take it away.
Hi, everyone. Thank you. So we can just move on to the next slide. So Adding microbial source tracking in-house really changes how and when we can use this technology. And that has like downstream impacts on cost and strategy, right? So essentially, there are excellent labs. One of Lumen Ultra that, the East Shore Health District used. We've worked with them, ourselves. So we aren't necessarily replacing, external labs that provide MST, but having it built in-house lets us use this technology more thoughtfully and in a really cost-effective and strategic way. So yeah, seems like. So in-house analysis can let us use MST selectively, strategically. Not every sample necessarily needs it. And so we don't have to commit to the cost up front. So when you send like a raw sample to an external lab, you're basically committing to like every step of the process. I'm not going to get into the nitty gritty, but there's like sample prep, filtration, and digestion, purification, and then the actual analysis of the different assays. So we can really cut that down. So routine testing, which, they've done like E. coli, we do entero as well, can take 24 hours for those results. So ultimately, we like to wait to see what those results are because if you don't really have, high enough of a bacteria result, you don't want to have to proceed with the DNA analysis. So that will save us. Wait, not quite.
Oh, sorry, Lena.
I'm almost
Apologies.
getting there.
Sorry.
So, you know, because of that, so with in-house microbial source tracking, that decision window becomes a lot more flexible. So basically, faster pivot, when results are high from routine testing, we're going to be able to lower sample costs over time. And we're going to be more responsive to support our community. And I know Sarah, a few months back, reached out to me. We're not quite set up, which I'll get into that yet. But the hope is that when they come to us and like, hey, we have a few more samples that we want to get tested, like, yeah, we can do it. We can help you out.
Yeah.
And we can, provide a more cost-effective, option. So essentially, we'll be selective, responsive, and efficient with that. So part of that, this, was, thank you to the Long Island Sound Stewardship Fund. And, because of that, we were able to purchase the instrumentation and lab equipment needed to conduct quantitative PCR, which is the specific technique that is used in MST analysis. And that is important to keep in mind that, qPCR is the core technique, which we're set up, and it has like a wide, varied application, you know, purpose to that. So I'll get into that in a little bit. In addition, we were able to kind of build out capacity in our lab in terms of, really thoughtful rearrangement of, our existing supplies and lab equipment. It doesn't just require the core like PCR instrument. It required supplementary supplies, and we needed to be able to make sure that we created the right environment for what at its core is DNA analysis. And this funding is, that allowed us to implement, this to our laboratory isn't just like a one-time project. It's a long-term investment. It is a tool, which I'm going back to quantitative PCR, that will allow us to do microbial source, bacteria analysis, but it's going to also allow us to eventually someday, do biodiversity assessments. So qPCR is also used in, detecting and quantifying, maybe like river herring and other type of fish
Yeah.
species and macroinvertebrates. So next slide. So I basically spent the past year just really focused on learning, testing, and setting up the lab. I'm currently finishing out validation of the human associated fecal assay. It's called, HF183 is the specific genetic marker. And it just basically involves, certain, validation tests. I went to a wastewater treatment plant locally to collect, raw sewage. I collected Peter's Fitz is dog poop, geese poop. So that way, it's very specific to our region because, I think Sarah kind of indicated there's no direct, comparison if you're doing different types of, markers, canine, avian, or human. So, but it's important to run these tests on our local kind of, source of feces. And so I'm getting everything ready before, this summer so that we're ready to go. And again, we're starting off with, the human assay. So I think if we can just kind of rule that out as, a main source, then we can then look to, canine and bird species so that, we can further distinguish between animals, domestic animals, pets, and wildlife. And so, but yeah, and so I'm just working on making sure that we're doing this in phases because we want to be very thoughtful. We don't want to rush it. We want to really build confidence first and provide really reliable results. And so that's why it took me this past, 2025 year and just finishing out my validation tests to make sure that this happens.
Thank you, Elena. My dog Fitz was happy to contribute to the effort.
I did gag a few times sampling
Yeah,
that.
Elena literally had to go through Fitz's poop. But Elena, if you know Elena or if you don't, I'll tell you, she is the person for this job. You did such a phenomenal job with your research and setting us up to be able to deliver really reliable, high quality results. So thank you so much for what you've done. And I just want to stress something Elena mentioned too. We do fully intend to offer this to the whole Long Island Sound community, running these samples. As long as it's in the Long Island Sound watershed, it fits our mission. We have to be somewhat selective, but one of the intents of bringing it in-house is being able to offer it to other groups, maybe other community groups around their beaches. We're going to be using it at 70 locations that we monitor seasonally from Greenwich through Westchester into Queens and the Bronx, to help identify hotspots of bacteria that also need more immediate attention, maybe because of human DNA, which can be one of the more serious sources of pathogens in our waterways. Like if we're interacting with human poop, it's a little different than dog or geese poop. So anyhow, Elena, thank you so much. It's really a pleasure working with you and phenomenal job with that project. All right, so we have about 8 minutes. I'm sure the core team can stick on a little bit longer. I've seen a couple questions. David, can you let me know, are there a bunch in the Q&A too? Just so we get a sense of how many we have.
Yeah, there are 5 in the Q&A. There's the one in the chat that you saw, and people can also, chime in here out loud. But why
All
don't we
right.
bang through the ones that were submitted, and then we can keep it open.
Okay, great. You want to do the chat first? Is that what you're saying?
Yeah.
Okay, well, we'll go back and forth. All right, so Tina is a partner of ours in water quality monitoring for quite some time. Tina, it was great to see your question. I had asked a similar one, Sarah, so if you could maybe briefly just let us know why E. coli was used instead of Enterococcus, which is the more typical brackish water bacteria.
Yeah, it's an important distinction. So starting in 2023, we've been collecting our water samples from the storm drains. So this is the fresh water that gets collected in the storm drains. These are cleaned before the start of the season, but the water that we're sampling is fresh, which is why we use E. coli.
There you go. And that was perfect, nice and short. I'm not going to keep talking about it. It is fresh water, so good answer. Kurt had a long comment. I'm sure it was friendly. Knowing Kurt, we'll get back to that. Jay, how new is this technology? Does Westchester County DOH have this technology? If not, why not in your view? So, you know, eDNA, qPCR sampling, it's not brand new. It's just hasn't been applied at a wide scale. It could be cost prohibitive. Some of the labs that do have it, like EPA Region 2 has it in their laboratory in Edison, New Jersey. I think USGS has it in Eastern North Shore, Long Island. And there's others, but it can be expensive. Some of the supplies and the staff time and just setting up the laboratory in the first place, it can have a pretty serious price tag to it. Elena, go ahead.
Oh, no, I just wanted the science part of it. The first part of the question is,
Yeah.
PCR, has been around for some time, but
Yeah.
the specific, for example, the human genetic marker HF183, that was discovered back in 2003. And then the EPA created, a method for the specific assay back in 2022. So it's been around. It's just, with quantitative PCR specifically, that's the technique utilized. There's different types of assays depending on your target. And so there's just a lot of studies that's required to find that specific, gene sequence location that will work and provide accurate results. So
Yeah.
I would say, like, again, the EPA, put out the method back in 2022. So I think it's slowly getting traction now.
There you go. And I can talk so much, but it's great to hear from our presenters. So thank you very much, Elena. And Jay, I'm not 100% sure if Westchester County Department of Health's lab in Valhalla has this technology, but we are in touch with them with our sample results, and we will be sharing the sample results we collect in Westchester with them in, Blind Brook, Mamaroneck River, Sheldrake, if you're in this area, just like we will with New York City DEP and health officials in Nassau, Suffolk, and other areas in Connecticut where we sample. Um, Hi, it's nice to see you. Yop. So great question. 2025, I can answer this one, was a drier season. So it was a drier season. There were a bit fewer wet weather samples that were collected, I would say, across the board. Um, so, that can play in a little bit to some of these results. So something important to keep in mind is precipitation and the impact. Sarah, did you want to add anything to that?
Yeah, so that's total season precipitation was a bit lower in 2025. But the precipitation that really matters is what's happening in about the 2 or 3 days before we collect the sample. So in our case, we were really interested in the slope of the line. How does precipitation affect E. coli that we measure? And we have seen a decrease in that slope. So even if total precipitation was not comparable between years, between the events we were sampling, we were seeing improvement in water quality.
Of course. And you did targeted sampling too. So you were going out, you're right, you were targeting wet weather. So dependent on this, yeah, good. I won't add to your answer. Thank you. Rick, do
I can answer the
samples
first question.
do it? Let me read it out loud though. Do samples require refrigeration, and what is the time frame to get samples to a lab after collection, Elena?
Yeah, I'll leave the rest to Peter, but
Okay.
um, as far as refrigeration, yeah, when you initially collect it, so there's a couple different methods of collecting it. You can filter out in the field. There is a preservative that can potentially allow you to, well, not potentially, it can allow you to store the filter at room temperature for an extended period, several weeks. Or if you do refrigerate it, make sure it gets filtered, and if you're, within 24 hours, and make sure that filter is frozen at -80, if you're not using preservative, and that'll last for about 18 months. So there's different techniques, which I'm not going to get further into, but.
Rick, you asked for it. You got it. You know Elena, just like me. Thank you. That was a good, punchy answer. And do we have funding? Yeah, we have some funding just because we're interested in running these samples, refining the method. So we'll take some samples from some of the groups we've been talking with preliminary around the sound, but we'd like to work with groups to build this into their grants, to find the funding to fund this effort at a larger scale. And our cost per sample, we're not here to undercut private labs or some of those labs that we know like Lumen Ultra that are doing phenomenal work, but the price tags are steep. It can be cost prohibitive. You heard us mention that. And as a, nonprofit organization, we're out to cover our costs. We don't have a ton of overhead and other things. So I think when we talk in those discussions, you're going to see that our price tags are lower. We're not as cost prohibitive for groups that want to run a lot of samples. So David, why don't we go to the Q&A and then we'll get back to the chat. I just see the chat, so give me some Q&A or us some Q&A.
Yeah, I'll fire these. These should be kind of quick. There's a series from Amanda here who asked, Sarah, what was the diagnostic testing lab that you mentioned that was used for MST?
That was Lumen Ultra Labs.
Okay, great. And then Elena, what was the threshold concentration that you used to trigger MST testing for using qPCR?
Oh, I when we generally we would like to see our results go if for entero, for example, above 1,000 or higher. If it was, just exploratory. But I don't want to say straight out because, it'll be dependent on the project.
Yeah,
We might want to just do across the board analysis to characterize several different stations. So, I mean, it's dependent. I think
it
if
is.
we,
It is.
yeah. So,
Yeah,
Great.
good answer. It's dependent on the location too. We're sampling. Is it a beach? Is it a river? Is it, we want to take into account any criteria that apply. Go ahead, David.
Yeah, just I'm going to let everybody know it's 1 o'clock, but we could stick on for a couple of minutes and answer a few more questions, and then anything that doesn't get answered, we can, when Amanda shares out the link to the presentation, we can answer some of those questions there as well. But this is for Elena. Elena, I've asked you this question many, many, many times, as you know. Did you base your SOP on EPA Method 1696? You and I have
yeah,
always
you
talked
got it.
96, 97, whatever it takes.
Yes, I did.
Yes,
And
yes, she did.
I actually communicated with one of the authors of the method.
Great. Here's one Branford specific question. So I don't know if it's Selectman or Mike or Sarah, whoever this is, but has Branford developed a toolkit for planning and implementing microbial source tracking and the canine waste program?
Excellent question. As part of this project, we would like to have it replicated in other municipalities. So that's something that's in the development stage. So on the education side, we've already done some of that work. And as part of this project, and I should also note that this is Sarah's PhD, that is going to be part of the project.
Great. I think we have a couple of time for maybe another question or two. There was, Kurt had mentioned something earlier. Peter, you had mentioned it early on about Sound Health Explorer, and I put the link in the chat early on. Can Sound Health Explorer be used to identify the beaches that have comparatively high bacteria levels that call out for intervention?
Yeah, I mean, that's a shout out from our former president who knows the answer to that one. But it definitely can, and he's done it before. So thank you for putting it in, though, Kurt, and setting it up. I'd really encourage people to go to Sound Health Explorer, go to their local beach that they like to swim in. There's over, oh, wow, we've got decades of data in there now and beach grades. So go in, take a look. It's really great at highlighting beaches that do need restorative efforts and where water quality can be a bit of a challenge. We heard from our partners up in Branford today, but there's other spots around the Sound that Save the Sound's active in. Other groups are active in too, to restore beach water quality. So soundhealthexplorer.org and go to the swimmable section. The new beach grades, and Mike got to show the 2025. That was in our information sharing. Mike's been great in sharing information with us. That 2025 grade that Mike shared hasn't been posted yet on Sound Health Explorer. We let him sneak that one in, and we're happy to actually, Mike. But the new beach grades are coming out May 19th. So keep an eye out for communications on the next set of beach grades. And really encourage you to take a look. And if you're not happy, say something. Say something to your elected officials, your community members, your local nonprofit, whoever it may be, but change is possible as we heard today.
And just to clarify, those are our beach grades that we'll be sharing out, not a published beach report that comes out biennially, but we will be sharing these out, and a lot of media outlets always pick up the beach grades, so it should be pretty easy to find that, but you can also find it on our website. And when we share out this link, the recording to the webinar will include the link to the beach grades page and the beach report page on the website. So I see more questions coming in. There are still some that we haven't gotten to, but I think it's probably a good time to let everybody go. All of our presenters who have been here since some were camped out overnight to be here early, to be here on time, so no one would get snowed in and not be able to get here. But any questions that were not answered here, I will make sure get answered in that email. But Peter, back to you, and thank you to everybody.
Well, I just want to thank everyone for joining us today. Thank you all. It was a really great group, really good representation from the entire Sound community, which is awesome. New York, Connecticut, different stretches of the Sound, and really just an encouraging story that we were able to tell. So thank you to the presenters that joined us. Just like David said, we'll follow up on any questions that were unanswered, and spring and summer's around the corner. We'll be enjoying our beaches soon. Thank you all very much.